Hi everyone, in this video I am going to explain first chapter in the first unit of signals and system. First we are going to see introduction to signals and system. The subject signals and systems give the properties of signals, properties of systems and interplay between signals and system, that is interaction between signals and systems. If the signal x of t is transmitted through a system, we get output y of t. We have to process the signal suitably. For that purpose, we need a system. Without system, we cannot transmit the signal in a proper manner. We have to extract certain behavior from the signal, then only one can find what kind of system is to be designed. The interaction between signals and systems are fundamental importance. Okay, see, input x of t is given to the system and for the input we'll get the output y of t. Next, we are going to see what are the standard signals available in the signals and system. The first one is step, second one ramp, third one pulse, fourth impulse, fifth real and complex exponentials, and sixth one is sinusoids. Next, I am going to explain what are the branches, signals and systems applied. The first one electrical. Under electrical, it is applied to smart grid and power system, etc. Then electronics, television, mobile phone, communication system, wireless system, Wi-Fi, etc. And instrumentation and control system, biotechnology, astrology, acoustics, seismology, etc. To process the signal means that is to extract the certain behavior of the system. What is the aim of the signals and system? To study the properties of both continuous as well as discrete time signals and systems. Next, I am going to explain what is signal. A signal is defined as any physical quantity that varies with time, space, and any other independent variable. Anything that carries information is also called signal. First of all, we are going to see the examples of signal. Image in space, that is 2D signal. See, the image that depends upon x coordinate as well as y coordinate. So two independent variable x and y. So this image in two-dimensional space. So the signal is otherwise known as two-dimensional signal because it is having the independent variable x and y. Next, I am going to explain multidimensional signal in space and time. When a function depends upon two or more variables x, y, and z and so on, so that is known as multidimensional signal. Here in this figure that shows the three-dimensional view of dogs. Next, one-dimensional signal. Human speech conveys information that is known as single-dimensional signal. The function depends upon single independent variable time, so that is known as single-dimensional or one-dimensional signal. We are going to see another examples also for one-dimensional signal, natural signal, electrocardiogram that provides the information to the physician for analyzing the heart condition of the patient. Next, I am going to explain electroencephalogram or EEG. So that is known as natural signal, that is brain signal. It is also the biological signals, thereby helping the physician to diagnose the various abnormalities in the brain. Next, time signals can be expressed in x of t and y of t. Sinusoid, speech, ECG, EEG are the example of information-bearing signals that is a function of single independent variable, namely time, are called one-dimensional signals. Image and video signals are two-dimensional signals. 2D signals can be extended to 3D, 4D, 5D and so on. Example, one member is speaking from a very long distance. How we identify his voice? That can be identified by removing the noises present in the speech signal. So we can process the signal, then only we can get a clear voice. Next, we are going to see what is input signal and what is output signal. Input signal, a signal enters the system from an external source is referred to an input signal. Example, the voltage from a function generator, electrocardiogram from heart, temperature from human body, etc. What is output signal? The signal produced by the system in response to the input signal that is known as output signal. Example, displacement due to force, output voltage of an amplifier. What is the input to the amplifier? There is small voltage. Is applied to the input to the amplifier, we get larger output voltage. That is amplified output voltage. Next, we are going to see what is system. System is a collection of physical components. System is associated with the generation of each signal and another system associated with the extraction of each signal. Signal is defined as a mathematical relationship between input and output. Any physical phenomenon represented using mathematical modeling is called a system. Example for system. A simple example for physical system is rectifier, which produces a pulsating DC output from the AC input. The input signal given is AC and we get the output as pulsating DC. A system can be defined as a device or process or an algorithm that manipulates one or more input signals that to accomplish a function, thereby yielding output signal, that is response. Next, we are going to see the first chapter, the first unit, that is standard signals. The first one is unit step signal. U of t is equal to 1 when t is greater than 0, 0 when t is less than 0, t is greater than or equal to 0. What is unit step? Unit step input is used to indicate a sudden jumps take place at an instant. Next, ramp signal. The ramp input is defined as R of t is equal to t0, t is greater than or equal to 0 and t less than 0. Ramp function is used to indicate a uniform change over a period of time. Third one is pulse function. It is defined as phi of t is equal to t when t modulus is less than or equal to lambda by 2. 0 otherwise. Okay, see, in between lambda by 2 and plus lambda by 2, we get the value 1. And remaining all other places, we get the value 0. Next, impulse function has 0 amplitude everywhere except at t is equal to 0. The amplitude is infinite and the area under the curve is 1. So this is impulse signal. Here this is the area under curve, that is 1. Next we are going to discuss real and complex exponential. How to represent the exponential signal first, that is e power alpha t. Here A is a constant. Depending upon the nature of A and alpha, the exponential signal may be classified as real exponential signal and complex exponential signal. In a real exponential signal, A and alpha are real. What is complex exponential signal? A and alpha are complex. First of all, we are going to see real exponential signal under three conditions. First, x of t is equal to a into e power alpha t. When alpha is greater than 0 and a is equal to 1, we get minus infinity. Put instead of alpha, put minus infinity 0. Minus 3 we get 0.0497. So I have to plot these values and finally I get the curve like this, lower to higher. That is alpha greater than 0. Next I am going to explain the second condition when alpha less than 0. So I have to put all the values here for a corresponding values. I have got the answer here upper to lower. That is alpha less than 0. When alpha equal to 0 is e power 0, that is 1, we get the constant line that is parallel to t-axis. Next we are going to see the real exponential signal application. If alpha is greater than 0, x of t increases exponentially with time is said to be a growing exponential. Example, chain reaction in atomic explosions, population growth, that is from lower to higher. If alpha is less than 0, x of t decreases with time and is said to be a decaying exponential signal, which is used to describe the natural response of RC and RL series circuits. Next, I am going to explain the next one, complex exponential signal. What is the general form of complex exponential signal? The general form of complex exponential signal is a e power alpha t. Here a e power alpha t is given in the equation, the previous equation, where both a and alpha are complex. A is expressed in polar form and alpha in rectangular form. Polar form is r angle theta and rectangular form is x plus jy. That is the rectangular form. Here I am going to put alpha in a rectangular form. So alpha equal to sigma plus j omega. So now here I don't substitute the value of alpha a. Directly I have to substitute the value of alpha. Have to separate these terms a into e power sigma t into e power j omega t. And next here for various conditions, three conditions I have to check the answer. For sigma equal to 0. When sigma equal to 0, I'll get the answer that is a sine waveform only. When sigma is greater than 0, it is similar to the growing exponential. So here sine waveform, if we mix the sine waveform with this growing exponential, we get the exponential like this. Okay, next sigma is less than 0, that is decaying exponential. So this is the decaying exponential. If we multiply the decaying exponential with e power j omega t, we'll get the answer like this. So this is the waveform. So in this way, we'll get these three types of waveform for complex exponential. Next, I am going to explain sinusoidal signal. This is the last one. A continuous time sinusoidal signal in most general form is x of t equal to a sine omega t plus pi. Pi is the delay, so omega t plus phi. So where A is the amplitude, omega is the angular frequency in radians, phi is the phase angle in radians. Figure shows the waveform of the sinusoidal signal. The sinusoidal signal is an example for periodic signal. The time period is always same, 2 pi divided by omega. Okay, these are about sinusoidal signal. That's all. Thanks for watching. Have a nice day.